Let's define a function that looks something like this expression here. So we'll let f of n be the square of a sub n plus 1 and the square of a sub n over their product. So we're interested in n is 2006, and finding the largest integer less than or equal to means we want to find the floor of f of 2006. This product in the denominator suggests that we can write this as the sum of two fractions, one with a sub n plus 1 in the denominator and another fraction with a denominator of a sub n. The product will give us a common denominator that we can use. Setting the numerators equal to x and y, we can find a common denominator by taking the product. So our numerator here will be x times a sub n, and this is y times a sub n plus 1. We can equal the left-hand side when x is equal to a sub n and y is equal to a sub n plus 1. So we can rewrite this expression as the ratio of two consecutive terms in our series plus its reciprocal. In the problem statement, we're also given this relationship among three consecutive terms in the series. First, let's divide both sides of this equation by the product a sub n minus 1. On the left-hand side, a sub n minus 1 is going to cancel, and we're going to be left with a n plus 1 in the numerator and a sub n in the denominator. On the right-hand side, the a sub n is going to cancel with one of these. We'll have one left and an a n minus 1 in the denominator. And then we take the 2007 and divide by the product. We'll do the same thing, except this time we'll divide by a sub n plus 1. And on the left-hand side, the a sub n plus 1 is going to cancel. We'll be left with a sub n minus 1 and a sub n in the denominator. Here again, one of these a sub n's is going to cancel. We'll have one left, and then a n plus 1, and again 2007 over the product. I'm going to take this first equation and then reverse left and right. And now down here, I'm going to add these two equations. So on the left-hand side, we'll start with this one, and then these three terms on the right-hand side. Here again, we see the ratio of two consecutive terms and its reciprocal. This is f of n, and down here we can replace this with f of n minus 1. On the right-hand side, same thing, two consecutive terms added to the reciprocal. We'll collect these functions on one side of the equation and the fractions on the other. And I'll go ahead and factor out 2007. These similar denominators with the product of consecutive terms suggests a telescoping series, especially with this minus sign. We may get some cancellations. Let's find the sum of these values starting with n equals 2. On the left-hand side, we have f of 2 minus f of 1, and this is the right-hand side. And n equals 3. We're interested in n equals 2006, so we'll take the last two terms, n equals 2005, and n equals 2006. Now we'll add everything, starting with the left-hand side. I'll factor 2007 from all the terms. Here's our first pair of fractions, and so on. And now we'll check the telescoping terms. Here's f of 2 and minus f of 2. This f of 3 is going to cancel with the next term. These two 2005s cancel. This 2004 will cancel with the previous term. So what remains on the left-hand side is f of 2006 minus f of 1. And on the right-hand side, we have these two fractions, a2, a1, and a 2007, 2006. The problem statement gives us a1 and a2. They're both 3. Recall that f of n is the ratio of two consecutive terms plus its reciprocal. So we can find f of 1. That's a1 over to a2 and a2 over a1. That's 1 plus 1 is 2. We can make these substitutions. Here this product is 9. We'll solve for f of 2006. We'll distribute the 2007. Dividing by 9 is 223. I'll add 2 over here, and then we're left with this fraction. We're trying to find the floor of this expression, and the only unknown is this fraction. So let's rewrite the right-hand side like this, and we'll see what happens to this denominator as n gets bigger. The first thing to notice is that our two starting terms are both positive. And from this equation, when we solve for a sub n plus 1, inductively we see that when the denominator is positive, and then we have this perfect square in the numerator, this fraction is always going to be positive. And so all terms will be positive. We also found earlier that when we take this equation and divide by an minus 1, we get this equation. Our starting ratio here is 1, and then we're adding a positive number to it. So subsequent ratios are going to be even larger. For example, when n equals 2, we have A3 over A2 is A2 over A1 plus 2007 over the product A2, A1. This adds up to 224. The next ratio, when n is equal to 3, we're going to take the previous ratio, 224, and add another positive number to it. These consecutive ratios are always increasing, so our AIs are increasing as I gets bigger. A3 over A2 was 224. Solving for A3, where A2 is equal to 3 again, this is 672 for the third term. So we know that A sub 2006 and 2007 are going to be bigger than 672. If that's the case, then their product, A 2006 and 2007, is going to be greater than 672 times 672. This is clearly greater than 2007. So when we look back at f of 2006, we have an integer 224, and then we're subtracting a very small fraction from 1. But in any case, this expression here is less than 1. So when we take the floor, the greatest integer is going to be 224, and that's our answer. If you'd like me to solve any other math contest problems, please leave them in the comments.